Welcome to my channel. In this video, I'll explain how to program a flight controller with ArduPilot firmware and set the parameters to build a differential thrust system for your RC boat. A differential thrust system relies on two motors positioned at the left and right rear of the hull. By adjusting the thrust and direction of these motors, the boat can maneuver in any direction. If both motors spin at the same speed, the boat travels straight forward or backward, depending on the thrust direction. Varying the speeds or directions of the two motors generates torque, and the torque strength depends on the distance between the motors and how much their speeds differ. For turning, just run them in opposite directions. This pivots the boat around its own axis. Paired with a flight controller, these systems can even navigate and return home autonomously. A great firmware choice for this setup is ArduPilot. It handles boat steering very well. Now, let's get into the steps to set this up. First, flash the flight controller, FC, with compatible firmware. For boats, use ArduRover firmware. I prefer Q-Ground Control for programming and parameter setup because it's more user-friendly. You can program the FC online or offline. In online mode, Q-Ground Control auto-detects the FC, finds compatible firmware, and flashes it automatically. In offline mode, download the firmware from the ArduPilot website based on your FC type. Then, flash it manually. Once flashed with ArduRover, calibrate the accelerometer, compass, and radio in the Sensors tab of Vehicle Setup. For accelerometer calibration, place the FC in 6 different orientations. For compass calibration, rotate the FC fully around all 3 axes X, Y, Z. ArduPilot uses the throttle and roll channels for differential thrust. Assign the correct radio channels during calibration. Note, most RC transmitters' throttle stick isn't ideal for bidirectional BLDC motors, as the down position means full reverse. I use the pitch channel for throttle, it's auto-centered. So, channel 2 is throttle, channel 4 is roll. After calibration, verify RC2 trim and RC4 trim are around 1,500 microseconds. Now, let us set the ArduPilot parameters of flight controller in Vehicle Setup. In the Frame tab, set frame type to boat. In the Flight Modes tab, assign channels and modes. My transmitter has push buttons on channels 5 and 6. I use a 3-position switch on channel 7 for flight modes. Main modes for RC boats: manual, hold, and loiter. Assign these to the 3 positions on channel 7. Auto and RTL are autonomous modes, as well as loiter mode. GPS lock is required for these modes. These modes can be assigned to another channels. When I flashed the firmware, serial settings for GPS and RC were pre-configured in the Serial tab. Check yours against your FC's datasheet. In the Miscellaneous tab, set pilot steer type to 0, default for differential thrust. Servo functions are crucial. Assign based on physical motor connections. Set Servo 2 function to throttle left and Servo 4 function to throttle right. These must match your roll, channel 4, and throttle, channel 2, assignments. In manual or ACRO modes, this ensures proper control. In my setup, the left motor connects to PWM output 2, right to output 4. In the RC tab, assign other functions like ARM, RTL, or activations. Channel 5 is a latching button, so I use it for arming. Other buttons and switches can be used for additional tasks. For ELRS RC with telemetry, set RC options accordingly. For simplicity, disable arming check in the Arming tab initially. Re-enable later for safety if you want. In the Log tab, enable log backend type, set to 1 for file logging, to review logs post-test. Use them to tune PID rates. Set log disarmed to 0. It disables logging when disarmed, saving space. Defaults are usually fine. For failsafes such as low battery or communication lost, set the FC to return to launch, i.e. arming point. In the FS tab, set FS action to RTL. In the BAT tab, set BAT FS LOW act to RTL. You can choose hold instead for low battery, but RTL is standard. For smooth and stable navigation, decrease waypoint speed and increase the waypoint radius in the WP tab. As a final note, some settings might confuse you at first. Wrong configurations can waste a lot of time. Channel assignments are set during radio calibration. Just move the sticks as prompted. Or remap channels afterward if needed. Make sure your roll and throttle channels match the servo numbers. Mismatches lead to tedious issues. Finally, let's test the differential system. Switch to manual mode and monitor the motor outputs to check if everything works properly. Thanks for watching.